Greetings to everyone. My name is Samuel Mbogwa, and I'm the one who will be handling this unit, Calculus 2. And Calculus 2 is an advancement of Calculus 1. And if you recall in Calculus 1, definition of calculus is, we say calculus is concerned with the mathematical analysis of change or movement. And there are two basic operations in calculus. The first one is differentiation that you covered in Calculus 1, and the second one is integration. So these two basic operations are reverse of one another in the same way as addition and subtraction or multiplication and division. So particularly, we'll be looking at the various methods of integration. We'll be looking at power rule. We'll also be looking at the integration by parts, integration by substitution. Then we'll be looking at the trigonometric substitution and definite integrals. Of course, we'll have covered the indefinite integrals in the first part. Then from there, we'll be looking at the applications of integration, length and the area under curve, how it is used in calculating the surface area and the volume. And ultimately, we look at the trapezoidal and Simpson's rule. So I'll urge everyone to be keen on the materials that will be shared in the portal, the quizzes and the discussion forums. Actually, they form part of the coursework. So kindly, I'd urge everyone to score all the marks in the coursework, so that when it comes to the exam, you'll only be looking for 40 marks to score an A. Many students have passed before, and therefore you are not an exception. So allow me to immediately go to the first topic, which is introduction to integration. And just as I've indicated, integration is the reverse of differentiation. So suppose we differentiate the function y is equal to x squared. We will get 2x. So integration reverses this process, and we say that the integral of 2x is x squared. So pictorially, we can regard this as what is displayed here in figure 1. So our function is x squared. If we integrate, we are going to get, if we differentiate, we are going to get 2x. And if we integrate, we are going to back to x squared. In other words, or if you recall, we normally say, or if you are to integrate the, not integrate, let's start by differentiation. If we were to differentiate our function, which is x squared, we are going to get 2x. So by differentiation, we normally multiply by the power and deduct 1 from the power. So our dy over dx becomes, we drop the power and multiply by the constant. Our constant in this case is 1. So 2 multiplied by 1, then 2 multiplied by 1x, then our power, we subtract 1. So that is differentiation. We times by the power, then deduct 1 from the power. Now, if we want to integrate, which is now the reverse or coming back, we normally add 1 to the power and we divide by the new power, right? So we are going to have 2x. So if we want to integrate, we are going now to add 1 to the power. So our x is raised to power 1. That's why it is x. You recall the rules. X raised to 1 is x. So if we add 1 to the power, we are going to have x raised to 2. Then we divide by the new power, which is 2. So 2x squared divided by 2, we are going to get x squared. So ideally, we are coming back. So what is supposed to be at the back of your mind is that integration is the opposite of differentiation. Whereas in the differentiation, we times by the power and deduct 1 from the power. For the integration, we now go back. We add 1 to the power and divide by the new power. Of course, we add a c, which is a constant. I'm coming to that. So the situation is just a little more complicated because there are a lot of functions that you can differentiate to give 2x. So here are some of the functions. Like you have x squared plus 4, x squared minus 15, x squared plus 0.5. So if you differentiate all these functions, you're going to get 2x, right? Isn't it? So all these functions will have the same derivative of 2x. Because when we differentiate the constant, we obtain a 0. Because our x here is raised to 0. Any number raised to 0 is 1. So 0 multiplied by 15 ultimately eliminates the constant. So consequently, when we reverse the process, we have no idea what the original constant term might have been. And that is why we add a c. So include a c in the answer, and this is what we call the constant of integration. Are we there? That's what we call the constant of integration. So we can say what we've indicated there, the three differ only by the constant of integration. So the derivative of a person or of a function gives the slope of the tangent line at any x value. So the tangent is the same, only that the constant will be changing. So we'll be coming into that later on. So we will represent the family of the antiderivatives of this form by fx plus c. Yeah. So all our functions will be of the form fx plus c, where c is the arbitrary value. So when you want to differentiate a function yx, we use the notation d over dx as an instruction of differentiating. But when we come to the integration, in the similar way, if you want to integrate a function, we normally use the symbol of integral. So this is the integral sign. For example, if we want to integrate 2x, this is how it will be represented. So this is the integral sign, 2x, this is the term, and we call it integrand. Then our dx is always put there to show that we are differentiating in respect with x. And then we have the constant of integration that you said we are going to add there. So note that along with the integral sign, there is a form or the term dx, and this must always be written. Now we say that 2x is being integrated with respect to x because our function is a function of x. So technically, integrals of this sort are called indefinite integrals. Now, they are called indefinite because we are not guided on the limit. Yeah? Where we are guided on the limit, for example, we'll be asked on the function of, let's say y is equal to 2x, spanning from 2, let's say, to 6. So that will be a definite integral. But where we've been given this form, we normally talk of indefinite integral. So I have an exercise there. we've been asked to write down the derivative of x cubed plus 17, x cubed minus 21. Try to understand what you just covered. And then part B, been asked to deduce that the integral of 3x squared is equal to x cubed plus c. This is the reverse. We are going backward. And then we've been asked to explain when, why, and when finding an indefinite integral, the constant of integration is always needed. So you know that the first one will give us our answer as 3x, and it will be, we are differentiating. No, we are integrating we are differentiating the x cubed. So this will be 3x squared. Remember the rule is 2 times by the power. So 3 multiplied by 1, that will give us 3. Then we deduct 1 from the power. So that will give us 3x squared. The same case to the second one and the same case to the third one. So the only difference from the other two is because they have a constant. So kindly note that. So whatever the constants, it is 0 when it is differentiated. And then we've been asked to deduce. Yeah, we are to deduce that 3x squared dx is equals to x cubed plus 3. Of course, if you integrate this one, now the integration will be the reverse of the differentiation. So we've times by the power, then deducted 1 from the power. In the other case, we are going to add 1 to the power, and then we are going to divide by the new power. So we are going to get the values as x squared plus c. Are we there? So on explanation, any constant will disappear, or it will become 0 because our x in that case is raised to 0 when differentiated. So one must be reintroduced, reverse the process, and make it complete. So there we are. We have the mathematical tables, and we could also use a table of derivatives to find the integrals. But the more common ones are usually found in the table of integrals in your mathematical table, and it is shown below. So these are some of the common functions that you are going to use in this particular unit. Yeah. So when you integrate a constant, you're going to get ax plus c. If you integrate x, you're going to get a half x squared plus c. If you integrate x squared, you're going to get a third x cubed plus c, etc. So if we were to form a rule, x raised to the power of n is like we are adding 1 to the power of n, and then we are dividing by the new power. That's why we have xn plus 1 over n plus 1. And then we add the constant of integration. But this can only work in all the other except when n is equal to -1. Because when n is equal to -1, then you can imagine if we put n is our -1, then -1 plus 1 is going to give us 0. And therefore, if we divide the entire product by 0, then we won't get any meaningful answer in integration. So when x is raised to -1, we normally get the natural logarithm in absolute of x plus c. Then the integration of cos x, this for trigonometry, so we'll be coming to that later. And then of course, we have the exponentials appearing there. So kindly note that you are going to use these rules and they apply. Now, for example, if you've been asked to use table 1 to find the indefinite integral of x raised to the power of 7. If that is the case, then you are going to apply the formula. And our formula will be, if I take you aback, we are going to apply this formula where we are going to talk of x is raised to the power of 7. So we are going to apply this formula. So it will be x raised to 7 plus 1, which is x raised to 8, all over 8 plus c. If we simplify that, it will be 1 over 8, x raised to power of 8 plus c. So kindly know that we'll be using all these rules all along. Yeah. If, for example, we were to use the table to look at the integral of cos x of x dx, then we are going to apply the rule. And when you apply the rule, we know that cos x dx is equals to sin x, sin of k, sin of the constant x over k plus c. So in other words, we are saying, in this case, our k is equal to 5. So if we were to integrate, we are going to get 1 over 5 sine 5x plus c. That will be as per the rule of cos. Go back and see we are saying cos k of x is equals to 1 over k sin k of x plus c. Kindly note that. And we've done so many given solutions of the different, but keenly look at, for example, this one. Find the indefinite integral of 1 over x. Yeah. So this integral deserves some special mention because you may be tempted to try and write the integral as x raised to power of -1. And if you use the fourth row of the table 1 of the formulas, you are going to lose it. Yeah, because we said that that formula cannot apply when our n is -1. And this is very clear because it will give us a 0. I had indicated that. Instead, our integral of x raised to -1 will give us natural logarithm of x absolute plus c. So kindly note that. We've been asked to integrate this. So this one will give us the integral of 12 dx. Yeah, it will give us, we are going to introduce. So what are you going to get? What are you getting? You're going to get, going to introduce x. So this will be 12x plus c. And for the second one, the integral of 12 dt. So you can see here our term, or we are integrating with respect to t. So kindly note that. So as you integrate, you are going to get 12t plus c. If you had been asked, for example, to integrate t raised to power of 4, t raised to power of 4 will give us, I've been given here as an example, it will be 1 over 5 t raised to 5 plus c. So kindly do a lot of practices. I'll be giving questions, or I'll be giving an exercise that you're supposed to go through and try to exercise. The other thing that I wanted to explain in this family of fx plus c, I wanted to explain on the constant multiple rule and the sum of difference rule if we are given such a case. So these are some of the rules of integration to enable us find the integrals of our range of functions than those normally given in the table. For example, if we be given a case here, the integral of k, f of x, where k is a constant. So a constant factor in an integral can be moved outside the integral sign as follows. So you can see we have this k function of x dx will be simplified into removing the constant outside the integral sign and then in working out the function separately. In other words, for example, if we've been given this case, find the indefinite integral of 11x squared, that will give us, our constant is 11. So we are going to get 11 outside the bracket. So we are going to have 11 outside the bracket, and then we integrate what is inside. So if we integrate what is inside, we are going to get x raised to 3 divided by 3 plus c. Then we open the bracket and our answer will be as simple as that. So kindly note that. Again, I'll be giving some few questions on the same. Now, if we were to look at the addition and the subtraction, or the sum of the, or the difference rule, the same case applies. We have the function f of x and we have the function g of x. Yeah. If we sum them, we are going to work the different functions independently, then amalgamate after that. So you can see what is happening. We are going to work or integrate the function of x and then later integrate the function of gx. The same case comes to the division rule. Yeah. So we are going to get the function of fx and then we get the difference with the function of gx. And these are going to be worked differently or separately. I'll give an example. See, for example, we've been given this example and you've been told to integrate or to find the integral of, in the bracket, 3t quadruped or raised to power of 4 plus the square root of t. Square root of t can be simplified into t raised to a half. So if we add them together, we are going to work them separately. So we start with the first one. So we are going to have, we remove 3 outside. So t we add 1, that will be t raised to 5 over 5. Then we open the bracket. So we are going to have 3 over 5 t raised to 5 plus, then we work this separately. You say that this is t raised to the power of half. So raised to the power of a half, if we add 1, 1 will be 2 over 2. So that will be t raised to 3 over 2. And then we divide by 1 over 3 over 2. And then its reciprocal will be 2 over 3, t raised to 3 over 2. Then we add c. Now, our constant of integration is only added once. There is no need of adding plus c, and it is the same c. Are we together? So again, I'll be giving some questions on the same, and you're going to attempt. Any question? Any question? So practice makes it perfect, and I want everyone to be interested in the computations of the integration, and this will ultimately help us or assist everyone understand this unit and the reason we are undertaking it. Of course, integration will be used in the analysis later on. We may be interested as the business managers in the optimization of the productivity in the business, and we'll see how this helps in the analysis later on. So I'll end it at that point. If you have any question, kindly drop it in the portal. Thank you.